Okay.
Hello, Victor. Thank you for coming. And we're here today to talk about your talk at Meeting C++, um, symmetry in code, should we care? Let's start with a little bit of an introduction. What are you doing with C++ and how are you?
Thanks for inviting me, Jens. It's nice to be here to chat for a bit. Also, super excited to tease a bit about my presentation coming up in a few weeks. So I've been doing C++ for many years now, and as of late, my focus gradually shifted more towards rusty things, and especially sort of bridging this Venn diagram between C++ and Rust, and sort of helping oxidation efforts going around in Microsoft and beyond, and how to bridge the two worlds, so to speak, the C++ code bases and Rust uh, projects and Rust endeavors, and how they overlap, how they interop, how they work together, how to build better tool chains. Because I'm in the Microsoft division in charge of building developer tools after all. So this is my focus of these past years, gradually transitioning from the C++ world to the Rust world, and filling these needs in these overlap areas, which is super interesting, especially in developer tooling space and compiler space, and lots of oxidation efforts in libraries as well. So going into the topic of my talk for Meeting C++ this year, as you sort of tease the topic and the title, it's it's about the symmetry, and it's interesting because it's not necessarily about spatial or geometric symmetry. That's sort of the most obvious thing, and interesting enough, also it doesn't really start with code. Whereas my interest in this topic started with physics, because I studied physics when I was younger, and my fascination with symmetry started there, because it shows up in many places, and not just symmetries, spatial symmetries that are kind of obvious, or temporal symmetries, or rather symmetries in phenomena and models, and how we formulate laws, and how we discover new laws, how we discover new particles, how we deal with these things in a standard model, and how looking for these symmetries allows us to identify new phenomena and new patterns, and simplify formulations, and simplify theories on natural laws in physics. So this is where sort of my fascination start with the topic, from gradual simplifications, from maybe Maxwell's equations for electromagnetism, and various simplifications that have been brought to those formulations using spatial symmetries, and then further simplifications using Einstein's simplified rotational symmetry, and symmetry using special relativity, and so on. So all these sorts of identifying these patterns and these symmetries, which can be in even in equation form, not just in phenomena, can lead to further understanding and simplification, and optimizing in the way you look and formulate physical laws. So I try to see if same kind of analysis applies to the kinds of code we write, and it can be as higher up as architectural symmetry in how we design components in interactions and physical models of these components, and how they connect to each other, and how they talk to each other, and how they move data around, but also symmetry in the actual code that we write in various programming languages, and the patterns that we're using, the idioms that we're using in code to model these dependencies, to model these data processing pipelines, and these data transformations, and propagating these notifications and these changes across the system. So I sort of try to to see where I could identify such things in code, either in how we design software products or how we actually encode a particular functionality in a function or in even maybe a bigger design unit in code in various programming languages, I would say. So it's interesting because you discover and you sometimes discover that symmetries can be beneficial. Sometimes pursuit of symmetry for its own sake can be detrimental, and sometimes symmetry can be incidental, not necessarily something deliberate or something that's it can or should be a goal. So I've looked at many things, and it's interesting to look. It's not just about sort of topology of code. There are very good presentations on this topic of sort of analyzing control flow through a piece of code, analyzing sort of the topology of the code, the shape of a program. I remember recently I've seen a very nice keynote from Lisa Lippincott on this topic. So I'm not trying to go down the path of sort of formalism or formal analysis of code, of loops, of termination conditions, of entry point, exit points, branching, and so on. But there are very interesting nuggets to be extracted from them. So rather than go through maybe synthetic or I would say rigorous analysis of these symmetries or these patterns in code shapes, I'm more likely interested in qualitative investigations and what kind of properties do emerge from these symmetries when we see them. So I'm looking like at ergonomics, like following some kind of or pursuing some kind of symmetry in a piece of code. Will that yield more simple piece of code? Will that yield something that's more ergonomic to use more by the client code, like to consume as a code? Will that be easier to maintain over time because of its symmetries and sort of regular shape it has? Or will it yield performance opportunities? Is it better for the optimizer? Is it something that can lead to better code gen through the shape of it, through how it's constructed, through its control flow graph? If is it something that's more amenable to better code gen? Things like branching and early exit points from functions, or encoding branching decisions in maybe reducing them in arithmetical operations, or encoding them as bit idioms rather than conditionals. How these kinds of things affect branching, or how these things affect instruction cache misses, or uh, these kinds of shapes, these kinds of branches in functions and all sorts of indentations, can they arise to better or worse code gen? And other kinds of symmetries that can be unraveled are things like loop unrollings and hoisting various variables across various points in the function body, and creating these sort of incidental basic building blocks for the function. Do they change in a meaningful way? Do they change the code gen? So can we sacrifice beauty in code and symmetries for better outcomes? Or what are the trade-offs? Like, when can we prefer these kinds of symmetries for ease of maintainability of the code and ease of extension of the code, and even reuse? For example, there's all sorts of interesting symmetries in generic code that are exploited for code reuse, not necessarily for programmer velocity or programmer or a better code gen. So it's these kinds of things that I'm willing to investigate, and I'm looking at them um, to to see if these patterns emerge, and in what way. Like, can we draw some conclusions? Are there are these observations purely anecdotal, and looking at them, and of course there's many interesting, like, amusing tidbits of noticing these kinds of symmetries, but can we actually get something meaningful out of these observations? Can we aim for some of these patterns or shapes to gain something, either performance or um, maintainability or scalability or ergonomics of usage and so on? So I'm trying to sort of examine all these sorts of things to see which of these are purely beautiful to look at and discuss, and which ones maybe should become goals for programmers, because they most often lead to something that's better in some way. Many of them can be incidental, but others are sort of good to follow as general principles whenever
But
we can, right? So I'm looking at all sorts of these kinds of symmetries. Um, any questions
so
from the audience? I want to stop now because
yes, so for like for developer, if you're like you go into your code base, how do you find those symmetries?
I'm tempted to start here with a funny bit. I remember a few years back, maybe 5 or 6 years ago, James McNeilis did the lightning talk at CPPCon that was enormously popular and hilarious. It was um, not accidentally called the shape of a program, and it started with, but although it was meant as a lightning talk, and it was extremely entertaining as a lightning talk, it actually hides some deep fundamental, I would say, incentive to investigate and dig more. And I highly recommend that people look it up and watch it. It's just 5 6 minutes, totally worth your time. And I would say it's a good starting point, because the whole setup of the lightning talk is about the shape of a program in terms of when you look at it, like from up far, and you squint at the code, and you sort of try to figure out the shape of it based on the white space you see around your code, like how
Hmm.
far indented it is, and that should probably give you an indication of how bad it is in some way. So trust me, it's much funnier than I'm describing it here. You must watch it. So I would say you can start from there. Sort of start looking at your functions, sort of by just trying to stand back and see how they unfold in front of you. First of all, in terms of size, in terms of the kinds of stages those functions have. If they're like too long, definitely they need refactoring, and how much branching you have, and how much control flow and inversion control you see, because these kinds of things are immediately obvious when you start, even if you don't if you're not exactly familiar with a piece of code, by just like looking at it and trying to figure out what are the uh, control flows in and out of that function, and potential inversion of controls, or non-local returns, or early exit points, or just look at the branching operations within that piece of code, you can get a feel for how complex or performance sensitive can be.
Hmm.
And again, it depends where you care about these things. I would say randomly looking for these kinds of things in your code can be fun, or maybe look at these kinds of things in PR reviews, because you definitely see these kinds of things in when you're doing reviews, especially for new blocks of code, not diffs, like inline modifications. So, but I would say like randomly looking for them might be entertaining, or you might learn something, but might not yield immediate results because it might not be actionable. Rather, I would say once you care about a particular piece of code, once you care about a particular component, either in terms of its design or its dependencies or its fan in and fan out in terms of data processing, then start narrowing down on that component, that class, that function, and look at it and see how the data flows into that function, how the data flows out of that function, what kind of processing is expected on the main, on the 90% of the execution path. What's the expected 90% of the execution path through this block, through this function, through this component? And then look at how this control flow is orchestrated within that piece of code, and figure out, is it shaped in the optimal form for how it's going to be accessed 90% of the time this program or this component is exercised. And even throw in the profiler and see how these things pop up, like what are the hot zones, like look at the at a profiler tool that you like and use, and try to figure out what's the profile, what's the shape of this piece of code I'm executing, what are the hot parts of it, and how do they even look at entry and exit, like look at the call stacks into that piece of code, like how is it accessed, right? What kind of operations are done before it and after it, and try to figure out, can you identify these patterns, can you see these uh, symmetries or asymmetries, because I haven't mentioned this this far along in the conversation, but there's many things that you can notice from asymmetries as well. And I'm
Yeah, it's I think
when I'm
something with that.
saying and when I'm saying asymmetries, I'm not implying there's something wrong there. Asymmetries can be the very thing you need in a particular thing, in a particular scenario. So, but look at those asymmetries and see, why are they in the way they're designed or in the way they're coded. Why is that asymmetry? Is that incidental? Is that significant in some way, right? So I would say this is like an looking at these symmetries in code. It's not an active pursuit you do for its sake. It's something you do as part of another activity you're doing. It's something you do when you're designing something new. It's something you do when you're refactoring a piece of code or a component. It's something you do in PR reviews. It's something you do when you're doing performance profiling and trying to figure out, why am I not getting the optimal code gen out of this piece of code, right? What are the implications? Why are these zones hot, and why is this piece of memory touched so many times? Why I'm not getting the code gen I'm expecting from this piece of code, right? So again, looking for these patterns and these kinds of symmetries in code, whether they're there or not, it's something you do as part of your day-to-day work. And once you see them, once you start to sort of have this at the back of your mind, when you do these other activities of design, refactoring, analysis, debugging, and so on, you will start to identify more. So once it's like that saying, like when you know about the the correct order of the colors in the rainbow, whenever you're gonna see like a children's book or illustration or something that has the rainbow colors in the incorrect order, like in the reverse order, you're gonna immediately notice them, and you never noticed that before, right? So whenever you acquire a new habit or a new way of detecting these kinds of idioms, they will start to pop up almost involuntarily. So when you sort of start to look at these things in this way, when you look at code or designs or components, you will inevitably make this part of your continuous rhetoric while you're thinking about a piece of code. So they, at least for me, they become like second nature. When I look at things, I immediately look to identify these patterns in code, and I try to see
Yeah, I think that's
if.
like
Go
I
ahead.
think it's like really interesting to think about like what symmetries there are in your code and how you can like learn or like for what symmetries you should be looking for. And one thing I had to think about before the interview, like in my own code, I often suffer that I have implementation asymmetries. So that one code path is more important than the other, and hence it's better implemented. And then, like, a typical example for me is like adding things to a collection is like well done, and then programming lean, adding the functionality to remove things when you need it.
Yeah.
And so
Yeah, people seem to optimize for the stuff they need right away, or for the stuff that they need more often, and all the other stuff sort of, it's like uh, gets second class treatment. So it's everywhere, but in many situations it's even more than that. It's I would say in many situations you can start to see these things in even in library design and language design. For example, I have in my presentation, I have a few examples of the guard pattern, which is um, it has become sort of popular in some programming languages like Swift and Rust. And some people even use this similar functionality even in C++. So, and it's all about reshaping the code, so you can write the same. It's kind of hard to hand wave my stuff without slides, but I think
yeah,
it's better this way because it's a teaser for people to actually see the talk,
yes,
because I have code, I
I do
have
think
examples.
that is a good example for symmetry, that we declare a lock guard and then have a lock being locked.
Yeah. So
And
it's all sorts of these things, but it's kind of hard to make a point without supporting slides and code, which I will have in the presentation. So it's
of course,
so things like guards and early returns and cancellation of operations, cancellation of asynchronous operation. And by the way, this is like a whole another level of interesting analysis on symmetries, is asynchronous operations. And asynchronous operations are very insidious in sort of corrupting the minds of programmers, because it's very hard to reason about asynchronous code in a straightforward fashion. And even when you get compiler syntactic sugar and state machine unraveling and making your code look sort of sequential, you have a lot of these kinds of targets in your code, and these are sort of the suspension points, the yield operations, the resume operations when you enter and re-enter a function, when you enter and re-enter a piece of code. So you have to judge and you have to think in terms of these: how do they affect my control flow overall for this component? Where is How is my data getting in? How is my function being resumed, right? What's the
yeah,
state
yeah,
that I'm resuming from? How does cancellation look for this component, for this data processing? Will the cancellation be in any way anti-symmetrical to construction? Like, these kinds of things is they can be very difficult to reason about. So when
yeah.
you talk about asynchronous code or coroutines or any
And
other.
I think you can extend this like to tests, right?
Yeah,
Your
even
test
test setup and
should be
teardown. Yeah,
symmetrical, because you need to test all the positive cases, but also then the negative cases, the error cases. What if I
yeah,
give you 0? What if I give you a null
yeah,
pointer? Um,
Yeah.
And we just had the case today in Germany that software which is designed to analyze an election and give the seats in the parliament got it wrong because they ended up on an input which they didn't test. And so they had to correct the results, or like not the results, but the seating, I think. But that was a
Okay.
software error, which seems to
That's
also be
a
like,
it's an expensive software
yeah.
error. You pay for it for 4 or 5 years, depending on constitution. Okay,
Oh well, they
interesting.
caught the software error, so I guess they corrected the seating because they
Okay,
didn't rely on the software 100%.
okay,
Which
that's good.
is a whole different topic when you have an error in the implementation and people rely on it.
Yeah, you know what they say
And
is the implementation is the truth. Like if the map and the terrain disagree, trust the terrain. So yeah, well, true. Tests as well. So definitely covering the positive and negative things. Also covering an important bit in testing is mutation testing. For example,
yeah,
mutation testing is specifically very interesting in analyzing these kinds of symmetries and flipping
and
things around.
finding places that you
Flip,
didn't cover.
exact, flipping your conditions, flipping your equalities and inequalities, flipping your less thans and greater thans, and so on. So all these sort of mutation testing, which it's like one of the important tools to harden your code and making sure your coverage is proper and your handling of the condition is proper. Mutation testing in itself is exercising these kinds of symmetries and asymmetries
So
in your code.
what is your plan to cover in the hour? Like, what's like kind of your outline of the talk in your head, and how do you envision?
Start from how I started, basically how I started today, sort of working my way through the motivation and how these kinds of identify and exploiting these symmetries in the character of physical law gives you a simplified, a better formulation for a physical law, simplified equations for these laws, and predicts new patterns and new particles and new phenomena. So sort of seeing how we can transplant these ideas and this way of thinking in our endeavors in programming, and then try to gradually work my way through symmetries in code design, symmetries in program shapes, symmetries for ergonomics, symmetries for performance, all these sort of control flow things, fan in, fan out in
Okay.
functions, control flow graphs, and inputs and returns from functions and so on, sort of how they affect the program execution and program maintainability. So more or less, I'm going to follow the same kind of pattern and agenda that I pitched now, but of course with some examples and hopefully some goals and calls to actions.
Sounds
So
interesting.
so my hope for the audience with this presentation is not necessarily to entertain them with all sorts of interesting examples and symmetry tidbits. My hope is to make them see the rainbow in the right order. Sort of when they go back and they do their debugging, or they do their performance profiling, or they do their refactoring, or they write a new piece of code, they sort of remember, oh, there was this talk that I saw at Meeting C++ about symmetries, and look, I can see something here that I either like or dislike, and let me see why I like it, let me see why I don't like it. Why is this piece of code shaped the way it is? And by shape, I don't necessarily mean like physical shape. It can be like how it's designed or how data flows in or out of it. And sort of make this a background thread in developers' mind. Make these identifying these patterns and idioms and shapes in code be the a background thread when they do these day-to-day things, programming or designing things, and they start to light up. So they will sort of involuntarily identify these things because now it's sort of a running theme for developers. So that's my hope. My hope is like I will sort of imbue this on the audience, hopefully.
Well, it sounds like an interesting talk. And what else are you up to with C++ at the moment?
Mostly exploiting how we can better bridge C++ and Rust worlds and improving compiler toolchains and libraries to have these worlds mixed together nicely because C++, Rust may be the hot new thing in town, but C++ is not going anywhere near soon. So lots of
Yeah.
C++ out there, lots of C++ being written out there. So the key to success is not to cannibalize each other. The key to success is making it work. Many companies are investing a lot of time and effort in making this interaction work smooth so that these large applications, large systems that are written in C++ can interop with newer bits written in Rust and so on. So the key to success is bridging these worlds, not fighting each other. So I'm spending a lot of my time at work these days at Microsoft, sort of bridging this, improving developer tooling, improving the Rust toolchain and tools and libraries so that everything works smoother with C++. And of course,
I imagine
lots of that
it's
stuff is C++.
a lot of work to make APIs available to Rust, which are in C++ implemented.
So, I didn't get the first part of your question.
It's not a question. I just
Oh,
generally I think it's like a lot of work to there's a lot of APIs which you want to access from Rust, but
oh yeah,
then you have to call into C++
yeah,
and to
yeah,
see that's
yeah,
like safe in a good
definitely.
way, and maybe want to private. So basically, as far as I understand, you're kind of also involved in providing Rust bindings that
Yes,
you are safe for people to use instead of having them roll
yes.
them on their own.
There's a team, and here I cannot help but not pitch the tremendous work that was spearheaded by Kenny Kerr in Windows. So there's a huge effort and a very polished and mature library. It's called Windows RS, which helps bridge these API worlds. So it
Mhm.
projects all the Windows APIs, all the system APIs, and from various subsystems in Windows as well. It gives you these nice language projections so that they can be consumed from Rust. Again, lots of effort went into that, and it's still going in, and it's a very polished experience. So again, the key is making these worlds work together nicely and have
And
less friction when they have to interop and have safe boundaries that you can use and have these components placed nice together. So there's lots of teams in Microsoft uh, investing in these kinds of efforts.
Interesting. Yeah, I just I plug one of my sponsors here, KDAB. I know they're also working on connecting C++ and Rust, and they have their own library and their own system to connect that. I don't know if you have looked at that.
No,
I suppose you have your own
y-
in Microsoft.
yeah,
Well, thank you for coming
yeah.
and
Thanks for
doing
having
the
me.
first interview. It was interesting to hear about your talk and the ideas about symmetry and code. Um, any last words?
Um, Come to meeting C++, folks. So aside from, I forgot to mention this. Like I reviewed all the proposals for meeting C++ this year, like I do every year. I was enormously impressed with the quality of the talks submitted, and the program looks amazing. I would say it's one of the best years yet. So,
Yeah.
but come to Berlin, or at least attend online if you can't come. But I would strongly suggest that you come to Berlin to the conference. It's so much fun, and the kinds of conversations we're having between the sessions, or at dinner, or even over breakfast, because we lots of us meet in the breakfast area of the hotel. So it's like being there is such a learning experience. It's so much fun. I get to meet a lot of my friends there, not just from Europe, but folks from US are coming. So I'm always like super happy to spend a couple of days there, and I always like when I do conferences, I always feel like super energized after that, and I learned a lot, and not just from the talks. So if you do come, and I strongly encourage you to, if you see me around, come say hi. Happy to chat. So come to the conference, folks. Looking forward to seeing many of you there.
Same for me. See you in Berlin, Victor. I'm looking forward to see you in 73 days it is today.
Wow, 73.
Yeah, it's getting closer and closer.
Countdown. Good luck
Indeed.
with the organizing.
Thank you, Victor. And so with that, I think we should close the interview. Thank you for coming, and see you
folks.
all in Berlin or online. The next interview will be on Thursday with Andreas Fertig, and